In this video, we will discuss solving linear equations with no solution or infinite solutions. So let's look at the first example. This is a linear equation, the variable y. We see some numbers are added or some numbers are subtracted from it, and then it is multiplied by some other number. So it is a linear equation. To solve it, we will collect the variable on one side of the equation and the numbers on the other side of the equation. So let's start by getting rid of the parentheses. Use the distributive property to multiply 8 by y, 8y, and then 8 by -6, which is -48, which equals 8 times y, which is 8y, plus 8 times 6 again, which is 48. And then we will collect the y's on one side. It doesn't matter which side we collect them. So actually we see 8y on both sides. So let's subtract 8y from both sides. And what happens when we do this step to collect them on the, when we attempt to collect them on the same side, we end up canceling both of them. So both of them ends up being cancelled out. And what do we have? We have -48 left on the left, which equals 48. Well, this is an incorrect statement. These two numbers are not equal. So whenever we end up with an incorrect statement, we can say that there is no solution to this equation. There is no y that satisfies this equation. Let's look at the second example. So here, again, we start solving this equation by getting rid of the parentheses, by distributing this 13. So 13y minus 3 times 6 is 18. 6 times 1 is 6. So carry the 1. So we have 78 plus 8 equals 13y minus 70. -78 plus 8 equals negative 70. So we have 13y minus 70 equals 13y minus 70. So you may realize that the left and right sides have exactly the same terms, same numbers. Well, you can realize it at this step and come up with your conclusion, but let's just carry this further. So sometimes you may not realize that they are exactly the same expression. So you may attempt to solve for y. So if you subtract 13y from both sides, actually, again, we canceled out all the y's. So the variable is no longer with us. So let's see, what do we have? We have -70 left on the left and -70 left on the right. So those are the two things that are remaining. Again, we have only just numbers, no more variables, and we see that these two numbers now are the same, different to the previous case where we had two different numbers. So this is a correct statement. If you want to add 70 to both sides, that's fine. You don't need to do this, but you can also say, okay, let's add 70 to both sides, and that's the most you can get in this equation. But at least you know that this is a correct statement. So you can realize it at this step, or at this step. In either, wherever you realize it, you can say this equation holds for any y. So we say that there are infinite number of solutions or infinitely many solutions to this equation, because it cancels out. Whatever number you plug in, it's going to cancel out and the equation will be satisfied. And in the previous case, whenever you end up with an inconsistent, incorrect statement, you say that there is no solution.